Welcome to Chapter 10, Section 8, the Power Theorems. In this section, we are going to apply a couple power theorems. And our first one here is the chord-chord power theorem. And we shorten this by CCPT. All right, when we call it the chord-chord power theorem. And what this tells us is it tells us that if two chords of a circle intersect inside the circle, then the product of the measures of the segments of one chord is equal to the product of the measures of the other chord. So if we look at this diagram here, we have chord FW and chord MT. They both intersect at point L, and so it divides into four segments, FL, LW, ML, LT. And this theorem tells us that FL times LW will equal ML times LT. Okay, now we can prove this quite simply in that we can prove these two triangles similar. We know we have vertical angles here, and so we have one pair of congruent angles, and then we can say that angle F and angle T are congruent because they intercept the same arc, MW. And so if two angles intercept the same arc, then they're congruent. Well, if the two pairs of angles are congruent, these triangles are similar, and if they're similar, we can use the means extremes product theorem to say that FL times LW is equal to ML times LT. All right, the next power theorem is the tangent secant power theorem, and just like before, we can shorten this up to say it is the T-SPT. All right, it's the tangent secant power theorem. And what this tells us is if a tangent segment and a secant segment are drawn from an external point to a circle, then the square of the measure of the tangent segment is equal to the product of the measures of the entire secant segment and its external part. All right, so let's pause and figure out what that's talking about there. Okay, so what this is telling us is if we have a tangent and a secant, so LT is tangent. L is the point of tangency. And if we have this tangent line and this secant, all right, it goes through the circle at 2 points, then this LT squared is going to equal, well, what does it say it's going to equal? It says the square of the measure of the tangent is equal to the product of the measures of the entire secant, so that's TF in this diagram, times its external part. Well, the external part is the part that's on the outside, TW. So we know that LT squared will equal TF times TW. This is the tangent secant power theorem. And we can use this to find missing parts. This side squared equals this external piece times the whole thing. Okay, next we have Theorem 97, which is a secant power theorem. And so you can probably guess, to shorten this up, we call it an S-SPT. So it's the secant power theorem. And it tells us that if two secant segments are drawn from an external point to a circle, then the product of the measures of one secant segment and its external part is equal to the product of the measure of the other secant segment and its external part. So let's take a look. We have a common point, P. We draw to B, and in doing so, we have to go through A, which is also a point on the circle. Well, from P, we also draw all the way to D, which in doing so, we have to go through C, which is also a point on the circle. And what this theorem tells us is that this external part, PA, times the entire secant, PB, has to equal this external part, PC, times the entire external part, PD. Now, one thing to keep in mind here, we are not saying that PA and PC are congruent, and we are not saying that PD and PB are congruent. What we are saying is that the two products are congruent. The external piece times the entire thing is equal to the external piece times the entire thing. Okay, well, let's put these theorems into action here. Let's take a look at this first one. And this, well, we have to identify what do we have. Well, we have a chord and a chord. So this is a chord-chord power theorem that we're going to use here. And what the chord-chord power theorem tells us is that 2 times 6 has to equal 3 times x. So 2 times 6 has to equal 3 times x. And so what is that going to be? Well, that's only going to happen when x is 4. Okay, now let's take a look at this one. This is a tangent secant, or a secant tangent, depending on how you want to call it here. So this tells us that the tangent piece squared has to equal the product of the external piece times the entire thing. So that means that y squared is going to equal 4 times the entire thing, which is not 9. The entire thing is 13. So y squared will equal 4 times 13. Well, that gives us y is equal to radical 52, because 4 times 13 is 52. And this simplifies into 2 radical 13. So we know that that segment piece is 2 radical 13, given that from here to the edge of the circle is 4, and this chord across the circle is 9. All right, let's look at one last example here, looking at our secant power theorem. And we're given that 3 and 4 are 2 external pieces, and we have an internal chord of 8 and z, and we want to find what z is. Well, our theorem tells us that if we take the external piece 4 and multiply by the entire thing 12, it has to equal our external piece 3 times the entire thing, which is z plus 3. Okay, and that's important. We have to remember that we want the entire segment of z plus 3 and the entire segment of 12. Okay, so we can use a little algebra to solve this, and we get 3z 3z plus 9 is equal to 48, and then we get rid of the 9 and we get 3z is equal to 39, and so z is equal to 13. Alright, we can double check that. 3 times 16 is in fact equal to 48, and 4 times 12 is equal to 48, and so we are good to go. This works. So take a look at your homework, try a few problems dealing with these power theorems, and I will see you in class.